Hey, fourth grade. Excuse me. Last lesson today involving circles and angles and such. And it's going to just be on like questions involving angles and circles, like some questions, that kind of come out of, rather than just circles and angles, like questions involving real things like cakes and clocks and compasses and other things that are circular and have angles. So write this as the title for your next free page. When you've done that, mark your page, close it up, and give me your concentration till we get to we do. So we've learned some stuff about angles and circles. We've learned first of all that if you take a circle and you start an angle in it, and you go all the way around the circle, an angle that goes literally all the way around the circle to where the first ray and the second ray are like back on top of each other. That is a 360 degree turn. And then we also did some things like this where we said, okay, well, if I make a 120, I'm going to estimate that. Say that's a 120 degree angle. What fraction of the circle is made by that 120 degree angle? Like if we were to, what fraction of the circle is this, or what fraction of the circle is this arc? And we said, well, that's part of the circle, and we can make a fraction by making a part and a whole. And the part is 120 degrees, and the whole all the way around would have been 360 degrees. And so there you go. It makes that fraction of the circle. You can do some equivalent fraction work and say, well, that's the same as 12/36, and that's the same as 1/3. And so a 120 degree angle would make 1/3 of the circle, or this part of the circle. So that's what we've done so far. So let's look at a question like this, say. It's Gia's birthday. She made a cake and needs to share it with the 7 people coming to her birthday party, plus a piece for herself, so that's 8 people. What angle should she use to cut each piece of cake? So imagine that, right? We're going to have 8 pieces of cake, and what angle are we going to cut them at? So let's draw 8 pieces of cake first. 8's a nice number, because when I think about trying to cut a cake into 8 parts, if I do it evenly, well, actually, you know what? I don't even think I need to do that. But I guess we can look at it just to kind of imagine what it would be like. So I'm not going to use my drawing to do it, and I'll tell you why. So let's imagine we're going to cut it into 8 pieces. 1, 2, 3. So the reason I'm not going to use, so we're cutting the cake kind of like that, right? The reason I'm not going to, I kind of made my drawing a little obnoxious on purpose. The reason I'm not going to just like draw this and then go get my protractor and measure the angles is because I did not particularly do a good job drawing it. I didn't necessarily partition it equally. And I think you should not assume that you're going to partition it equally either. So the way to solve this problem is not to say, okay, well, this one's going to be that, and this one's going to be that, because it's just not a precise enough drawing to just draw it into. But, anyway, that's what it's going to be. So it's going to be something like this. That can give me an estimate. It's going to be some kind of acute angle for each piece of cake, and we can go from there. So I'm not going to use a drawing to do it, and I don't need to, because check it out, because I really know, I know how many degrees are in the full cake. It's not given in the problem, but hopefully we're at a point where we know there's 360 degrees, in the circle of the cake. And I'm going to divide that 360 degrees into 8 different pieces. 360 divided by 8, whatever that is, ought to give me the right number, right? Each one, 1, 2, 3, 4, 5, 6, 7, 8, should have that section. So I know how to do that. I'm going to blast from the past. Let's divide 360 by 8 with the partial quotients method. So let's see. I can do groups of 10. That's going to take me a while. 8 times 10 would be 80. So why don't I do 2 of those? Why don't I do 8 times 20? 8 times 10 is 80, so 8 times 2 is 160. 8 times 2 is 16 plus the 0. That leaves me with 200. I'll do it again. 8 times 20 is 160. That leaves me with 40. And then I know 8 times 5 is 40. 40 minus 40 is 0. So there you go. So it looks like that is my answer, right? 360 divided by 8 is 45 degrees. So each piece of cake should be cut at a 45-degree angle, and then everybody gets the same amount. Pretty snazzy, huh? And that seems about right. Like, if I look at that, 45 seems reasonable in my bad drawing. That's an acute angle. Seems about right. And actually, it seems even more right if I think about this. Like, 2 pieces pretty much make a right angle, which is 90. And half of 90 is 45. So that does seem like a very reasonable answer if I use my logic and reasoning to check it out. All right, open your notebook. Let's do a different one together. How about this one? Let's do a clock question. Clocks are circles. Circles have angles. Clocks have hands. Hands make angles. Pretty cool. What is the measure of the angle formed by the clock hands at 1 o'clock? Let me make it 1 o'clock. There we go. So, I'm not asking you to measure in this case. I'm asking you to calculate. Obviously, you could just get a protractor and do it. But we're trying to develop some skills to do that in other ways. And so we will. So let's see. So I need to know this angle right here. The angle from there to there. Well, I don't know. It's pretty tough. I can tell that it's acute. But I don't really have a whole lot more information to use to figure that out. So let's use some reasoning here. So the way I'm going to attack this, I know all the way around the clock is 360 degrees. And so this is a fraction of the way around, right? It is 1 out of, let's see, 12, duh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, so what I could do, I can think of making the clock into 12 equal, like, wedges. Like, almost just like the cake, except it's a clock. Right? The numbers divide the clock 12 ways, 12 partitions, 12 pieces. And so I want to know what angle is this part. Just 1 out of the 12 pieces. So it's 360 degrees around, and there's 12 like pieces between, between 12 and back to 12. So I need to know what is 360 divided by 12. Can do. 360 divided by 12. Going to be kind of a pain to do at 12, but I can do it. So let's see. I'm just going to go in tens, I think. That seems like the easiest kind of thing to do. 12 is going to get a little tricky if I do bigger ones. So let's just do 12 times 10. It's 120. 0. 6 minus 2 is 4. 3 minus 1 is 2. Do it again. 120. 0 minus 0 is 0. 4 minus 2 is 2. 2 minus 1 is 1. Oh, and look what I got. 12 times 10 is 120. Easiest subtraction ever. And it looks like I made 30 groups of 12. So it's a 30-degree angle. Each one of these is 30 degrees. And that kind of makes sense, right? 30, 60, 90. And I do have like a 90-degree angle if I make 3. So that seems about right. 30, 30, 30. So at 1 o'clock, when all is said and done, at 1 o'clock, we have a 30-degree angle. So that's how you do questions involving angles and circles. There's usually going to be something round, and you can divide it into an equal number of parts. In this case, it was 12, because it was a clock. In the case of the cake, it was 8, because that's how many people were coming. And I take my 360 degrees, and I divide it into the right number of parts, and then I go from there to get my answer. Hopefully that makes sense. Lots of questions on the test like this. That's especially why I want to go over this. I think there's like 4. So please make sure you feel like pretty comfortable with these, because it was a little bit of a tough question. If you need to go back and watch this example again or the other example again, please do, so that you come to class really ready to go tomorrow and really comfortable with this. Once you have done that, you're all set. See you tomorrow.